Welcome to Unacademy, the largest online e-learning platform, and welcome to Unacademy Semester Exams. The course we are dealing is Network Analysis and Transmission Line. It's a crash course, and network functions is our topic of interest. And today we'll be dealing with impedance matching network. We'll be studying impedance matching network. So before that, let me tell you about myself. I'm sravan Kumar, having 7+ years of teaching experience and mentored more than 5K students for GATE and engineering services and also cracked GATE. Raju, welcome to Unacademy. Let me also explain you about the Unacademy Learning App installation procedure. Type Unacademy Learning App in Google Play Store. You'll get this app. Click on it. Click on GATE and engineering services and then click on this plus and click on get subscription, and you can use any of these options, plus or iconic. You'll get a dedicated mentor for your preparation in iconic subscription, and also you can use my code YSK10 to get the maximum discount of 10%, and click on proceed to pay. Once you click on this proceed to pay, you'll get the payment options: debit card, credit card, EMI, UPI, wallets and net banking. So you can use any of these payment options and get subscription to Unacademy, the largest online e-learning platform. Let me also tell you about Evolve for GATE 2022 and Ascend for GATE 2023. Evolve for GATE 2022 and Ascend for GATE 2023. The new batches have been started for this GATE as well as for the engineering services also. So there are new batches coming up, and there are some batches which have already started by our top educators of Unacademy. So hurry up and get subscription to Unacademy, the largest online e-learning platform. So that was about Evolve for GATE 2022 and Ascend for GATE 2023. Now let me tell you about this Unacademy Combat. It is India's largest fortnightly competition for GATE, and it's on January 12th, 2021, 6 p.m. for ME, CE and electrical students. And this has a challenging and original questions by our best Unacademy educators. The questions guaranteed to keep the test engaging, challenging as well as fun. So it's a super fast and fun with all India live leaderboard. See how you rank against others from all over India with a live leaderboard that shows real-time ranking after each and every question. Take it live to compete with the best. Know where you stand among all other contestants. Identify your weak areas and get detailed video solutions by the top educators. Get an in-depth video solutions for the questions right after the contest. So compete, crack and conquer. The score, you'll have this leaderboard as well as rating and awards. So it is India's largest fortnightly competition. Assess your GATE preparation in 65 minutes. Challenging and original GATE questions by our best educators, and take it live to compete with the best. And it is a super fast fun with all India live leaderboard. Soumya, good evening. Shivakumar, good evening. Welcome to Unacademy. And identify and improve your weak areas through detailed video solutions. The next combat goes live on January 12th, 2021 at 6 p.m. So you can register for free and use the code CRACKGATE to unlock. And the eligible branches are ME, CE and EE. So let me tell you about the competition format. The competition format is 60 minutes with 15 questions and 4 combats and 3 cohorts. Relative scoring will be based on the speed and the accuracy. Swarnasri, good evening. Srinivas, good evening. Welcome. So enroll now in Unacademy Combat. To participate in Unacademy Combat, sign in on the Unacademy Learning app in Google Play Store. To unlock, use the code CRACKGATE or also YSK10. Now, the topic for today is impedance matching network. So, let's see that. Impedance matching network. Let me tell you about this impedance matching network. A network that is inserted, a network that is inserted between a signal source between a signal source and load to achieve the maximum power transfer is called an impedance matching network, is called as an impedance matching network. So this is basically a circuit, a network that is inserted in between a signal source and load to achieve maximum power transfer is called as the impedance matching network. And it can be a T type or a pi type or a L type section. Now let me try to represent that. So if this is the source where you are connecting the excitation EG, and it has some resistance ZG, and this is T or pi or L section, that is an impedance matching network. And here you will connect a load to this network. Now let us consider this. Now let us consider a T type impedance matching network, and we will have to design it. So let us consider a T type, a resistor, or you can also consider it as impedances. So let us take this as Z1, Z2 and Z3. So now let us see, this is Z1, Z2 and Z3, and this is Zi1 and this is Zi2. Now let us write, we already know what is Zi1. It is under root of ZOC1 into ZSC1. Similarly, what is Zi2? Under root of ZOC2 into ZSC2. Alright. So now let's try to write what is ZOC1. ZOC1 is open circuit the second port and find the impedance at this point. This is ZOC1 through these terminals. Let's say this has 1 dash, and this is an open circuit. So if this is Z1, Z2 and Z3, then what is ZOC1? ZOC1 is equal to Z1 plus Z3. Similarly, let us try to find ZSC1. ZSC1, that means you have this network and you need to short circuit this and find the impedance here, that is ZSC1. This is Z1, Z2 and Z3. Now what is ZOC2? Sorry, ZSC1. ZSC1 is Z2 into Z3 by Z2 plus Z3 plus Z1. Now these two Z2 and Z3 are in parallel and it is in series combination with Z1. So you'll get Z1 plus Z2 Z3 by Z2 plus Z3. Okay, so this is ZOC1 into ZSC1. Just remember this, we'll use this in the next slide. So now let us find ZOC2. What is ZOC2? Consider this network. So this is open circuit. You'll find here impedance. This is ZOC2. This is Z1, Z2 and Z3. Now what is ZOC2? It is simply Z2 plus Z3. Similarly, now let us find ZSC2. Now what is ZSC2? Consider the same network and short circuit the first port. If you short circuit this port, this is Z1, Z2, Z3, and if you are finding impedance here, ZSC2, so ZSC2 is equal to Z1 into Z3 by Z1 plus Z3, these two are in parallel, plus Z2. So these are ZOC1, ZOC2, ZOC1, ZOC2, ZSC1 and ZSC2. Now let's try to substitute this. Let us call this as equation 1, this as equation 2, and let this be equation 3, 4, 5 and 6. Now let's try to substitute them. Substitute 3 and 4 in 1. So let's try to substitute. Substitute 3 and 4 in 1. When you substitute 3 and 4, that is Zi1 is equal to root of ZOC1 into ZSC1. What is ZOC1? Z1 plus Z3 into ZSC1. Let's try to look ZSC1. Z1 plus Z2 Z3 by Z1 plus Z2 Z3 by Z2 plus Z3. Now let's try to simplify this a bit. Under root of, I'll take Z1 into Z2 plus Z3 plus Z2 Z3 by Z2 plus Z3 into Z1 plus Z3. Now you can further write this as Zi1 is equal to under root of Z1 Z2 Z1 Z3 Z2 Z3. I'll write this as one term and I'll separate these two terms, this part and this part, as Z1 plus Z3 by Z2 plus Z3. So let us call this equation as Karthik. Good evening. Hello. Welcome to Unacademy. Now let us call this equation as 7. Then let's write Zi2 now. So to that, to write Zi2, substitute 5 and 6 in 2. Substitute 5 and 6 in 2. Now when you substitute 5 and 6 in 2, what is 2? Zi2 is equal to what? Under root ZOC2 into ZSC2. Now substitute these values. What is ZO2 actually? ZO2 is Z2 plus Z3. What is ZSC2? ZOC2 is Z2 plus Z3. This is ZSC2 is Z1 Z3 by Z1 plus Z3 plus Z2. Just look at that. Yeah, Z1 Z3 by Z1 plus Z3 plus Z2, that is ZSC2. Yeah, now substitute these values here. So Zi2 is equal to root over Z2 plus Z3 into Z1 Z3 by Z1 plus Z3 plus Z2. Now let's take this LCM in this part. So we can write this as Zi2 is equal to root over Z2 plus Z3 into, this is Z1 Z3 plus Z2, if you take LCM, Z1 Z3 by Z1 plus Z3. This is under the root. Now let's try to simplify this further as Zi2 is equal to root over, I'm just multiplying these inside, I'm writing it as Z1 Z3 plus z2 z1 plus z2 z3 into, I'll write these two terms separately, that is z2 plus z3 by z1 plus z3. So this is the value of zi2. So we already got zi1 7, zi2 as, let us call it as 8, this equation. Now multiply 7 and 8. Multiply 7 and 8. Now when you multiply them, what is zi1? zi1 is equal to root z1 z2 plus z2 z3 plus z1 z3. Just look at that. z1 z2 z2 z3 z1 z3 into z1 plus z3 by z2 plus z3, z1 plus z3 by z2 plus z3. This is zi1. Now write zi2, root over z1 z2 plus z2 z3 plus z1 z3 into z2 plus z3 by z1 plus z3. Just look at that, z2 plus z3 by z1 plus z3. Now if you multiply these two, what happens? zi1 into zi2 is equal to, if you just multiply these two, I'll just try to write it down, root over z1 z2 plus z2 z3 plus z1 z3 into z1 plus z3 by z2 plus z3 into multiplication, multiply this with root over z1 z2 plus z2 z3 plus z1 z3 into, what will get? This is z2 plus z3 by z1 plus z3. You can just write it down as, separate it, root over z1 z2 plus z2 z3 plus z1 z3 into root over z1 plus z3 by z2 plus z3 into, same way you can write this as z1 z2 plus z2 z3 plus z1 z3 into root over z2 plus z3 by z1 plus z3. You can cancel these terms, actually this root and this root, so all you'll get, this is root of root, both root will cancel and you'll get z1 z2 plus z2 z3 plus z1 z3. What is this is equal to? This is equal to zi1 into zi2. Let us keep this aside for now. So let us check what is, now what is zi1 into zi2 is equal to z1 z2 plus z2 z3 plus z3 z1. This is first part. Let us call this equation as 9. Now consider image transfer constant tan h phi is equal to, you already know it is z sc2 by zoc2. Tan h phi is equal to zoc2 zsc2 by zoc2. Substitute values of zsc2. What is zsc2? Just look at zsc2. What is zsc2? z2 plus z1 z3 by z2 plus z1 z3 by z1 plus z3. And what is zoc2? What is zoc2? It is z2 plus z3. z2 plus z3. Now let's try to substitute this in this equation. Let us consider this as, not consider this, that's enough. So tan h phi is equal to under root of zsc2 z2 plus z1 z3 by z1 plus z3 by z2 plus z3. Now write this as tan h phi is equal to under root of, just multiply this, z2 z1 plus z2 z3 plus z1 z3 by z1 plus z3 into z2 plus z3. You get this tan h5 like this. Now you can just multiply this, square this. First we'll square this, that will be easy. So let us try to square this. Tan h square phi is equal to z2 z1 plus z1 z3, sorry, plus z2 z3 by z1 plus z3 plus z2 plus z3. Let us call this as equation 10. Let's call this as equation 10. Now let us try to multiply this 9 and 10. Let us try to multiply this 9 and 10. What will happen? Zi1 into Zi2 into tan h5. What is Zi1 into Zi2? Just write it down. It is Z1 Z2 plus Z2 Z3 plus Z1 Z3 into what is tan h5 if you see. So instead of multiplying, you can divide this so that this term will get cancelled. So let's try to divide these two. Let's try to divide these two equations. Divide 9 by 10. That's better. So Zi1 into Zi2 by tan h5. What is Zi1? Write it down. Z1 Z2 Z1 Z2 plus Z1 Z3 plus Z2 Z3 by what is tan h5? Z1 Z2 plus Z1 Z3 plus Z2 Z3 by, there is another term, Z1 plus Z3, Z2 plus Z3, Z1 plus Z3 and Z2 plus Z3. We can cancel these two terms. You can Ramchandra Kumar, good evening, welcome to Unacademy. So you'll get this as Zi1 into Zi2 by tan h5 is equal to Z1 plus Z3 into Z2 plus Z3. We can write this equation as multiply that Z1 Z2 plus Z1 Z3 plus Z2 Z3 plus Z3 square. So this is Zi1 into Zi2 by tan square h. Sorry, this is tan square, right? So this is tan square h5. So once you get this value, you need to design. So you want the values of Z1, Z2, Z3. So to get the value of Z1, Z2 and Z3, what we will do is, let's call this as equation 11. Now we already know Zi1, Zi2. So subtract 9 from 11. So what we'll do is 9 minus 11. That's better. Yeah, 11 minus 9. Just do that. So what is that? Zi1 into Zi2 by tan h square theta. Tan h square theta minus Zi1 into Zi2 is equal to, just try to substitute the value. What is this value? This is Z1 Z2 plus Z1 Z3 plus Z2 Z3 plus Z3 square minus what is Zi1 into Zi2? Just look at that. Z12 2 3 3 1, Z12 Z23 Z31. If you see, you can write this further as Z1 Z2 plus Z1 Z3 plus Z2 Z3 plus Z3 square minus Z1 Z2 minus Z2 Z3 minus Z3 Z1. So when you get this, Z1 Z2 minus Z1 Z2, Z1 Z3 minus Z1 Z3, Z2 Z3 minus Z2 Z3. So from this, what did you get? You get directly Z3 square. So you can write Z3 square is equal to, write this towards right. zi1 into zi2 by tan h square phi. This is not theta, we have taken it as phi. Yeah, that is phi. So tan h square phi, tan h square phi minus zi1 into zi2. So this will be the value of z3 square. We can further simplify this. So let's try to write this in next slide and see what will happen. So z3 square is equal to zi1 into zi2 by tan h square phi minus zi1 into zi2. So you can write this as zi1 into zi2, if you just take common, it is 1 by tan h square phi minus 1. So what is z3 square is equal to zi1 zi2 into 1 by tan h square cot h square phi minus 1. But we already know that cot h square phi minus 1 is cosecant h square phi. So z3 square is equal to zi1 into zi2 into cosecant h square phi. We already know that cot h square phi minus 1 is cosecant h square phi, or cosec cot h square phi minus cosec h square phi is 1. So z3 square is equal to zi1 into zi2 into, you can write this as sin h square phi, because cosecant h square phi can be written as 1 by sin h square phi. So if you want to find z3 from this, you can write z3 is equal to under root zi1 into zi2 by root over sin h square phi. So this will give you zi1 into zi2 by, sorry, root over zi1 into zi2 by sin h phi. So in this way you'll get the value of z3. So z3 value is root over zi1 into zi2 by sin h phi. Root over zi1 zi2 by sin h phi is z3 value. So let's write what is z3 value. So z3 is equal to root over zi1 into zi2 by sin h phi. So this is the value of z3. Now let us try to find the other values also. For that, divide zi2 by tan h phi. What is zi2? Just consider zi2 first. What is zi2 we got? Yeah, this is zi2. So this is zi2, z1 z3 plus z2 z1, z1 z3 plus z2 z1 plus z2 z3 into z2 plus z3 by z1 plus z3. That is zi1. Now tan, let's write that value. zi1 is z1 z2 plus z2 z3 plus z1 z3 root over into z2 plus z3 by z1 plus z3 by tan h phi. What is the value of tan h phi? Look at tan h phi. What is tan h phi? Just take the value of tan h phi. Yeah, this is tan h phi. Under root of z1 z2 plus z2 z3 plus z3 z1 by z1 plus z3 plus z2 plus z3. z1 plus z3. Let's write this under root of z1 z2 plus z2 z3 plus z1 z3 by z1 plus z3 plus z2 plus z3. Now you can see this, you can cancel these two terms, and also you can cancel these two terms. What is that tan h5c exactly? It is z1 plus z3 plus z2 plus z3. Yes, you can cancel z1 plus z3 also. So what do you get? zi2 by tan h5 is equal to under root of z2 plus z3 by is equal to, we have root over z2 plus z3 into, this will also come in the numerator, z2 plus z3. So what is that directly? Z2 plus z3, root a into root a. So what can I write this? Z2 plus z3 is actually equal to zi2 by tan h5. Now what is z2 from this? zi2 by tan h5 minus z3. But we already know the value of z3. If you see, root z1 z2 zi1 into zi2 by sin h5, that is z2 is equal to zi2 by tan h5 minus z3 root over zi1 into zi2 by sin h5. So this is the value of z2, right? So these are the values of z1 and z2. And now also you can divide zi1 by tan h5. So this we have divided to get the value of z2. Now let's take zi1 by tan h5 to find z1. So consider zi1 by tan h5. What is zi1? If you see, just try to see what is zi1. zi1 is root z1 z2 plus z2 z3 plus z1 z3 by into z1 plus z3 by z2 plus z3, z1 plus z3 by z1 plus z3 by, yes, so this is under root of z1 z2 plus z2 z3 plus z1 z3 into z1 plus z3 by z2 plus z3. This is all under the root by tan h. This is also root over z1 z2 plus z2 z3 plus z1 z3 by, what is that value? Tan h. z1 plus z3 plus z2 plus z3, z1 plus z3 plus z2 plus z3. If you look at this, you can cancel these terms as well as these terms. So you will be left up with zi1 by tan h5 is equal to z1 plus z3 under root into root z1 plus z3. So you can further write it as root z1 plus z3 into z1 plus z3 is equal to zi1 by tan h5. So from this further you can write z1 plus z3, right? You can square this, and square and under root will get cancelled. You'll get zi1 by tan h5. So from this you can find the value of z1 as zi1 by tan h5 minus z3. So we already know that zi1 by tan h5 minus z3 is root zi1 into zi2 by sin h5. So now we know the values of z1 equations. Design equations will write in if by considering only purely resistive elements. Now let us write z1, z2 and z3. What is z1? zi1 zi1 by tan h5 minus root zi1 into zi2 by sin h5. Similarly, what is zi2? zi2 by, sorry, z2 is zi2 by tan h5 minus root zi1 into zi2 by sin h5. Similarly, what is z3? It is root zi1 into zi2 by sin h5. This is also written as zi1 by tan h5 minus z3, and this is written as zi2 by tan h5 minus z3, where z3 is this value. So if you want to find design equations by considering z1 is equal to r1, z2 is equal to r2, and z3 is equal to, sorry, by considering zi1 image impedances as purely resistive elements, that is zi1 as r1 and zi2 as r2, you can also derive them. So you can write design equations by assuming, in most of the questions will be given in terms of resistive, purely resistive. So we are writing design equations zi1 by assuming zi1 as r1 and zi2 as r2. So let's try to write that. What is z3 first? It is root over zi1 into zi2 by sin h5. That is, and when you consider purely resistive, there is another condition that phi is equal to alpha, or gamma is equal to alpha plus j beta, which will be only j beta. You won't have any attenuation. That is a lossless line. So being a lossless line, you won't have alpha. So it is gamma is equal to, or phi is equal to alpha plus j beta, which will be beta. Second, right, zi1 is r1, zi2 is r2 by sin h. Phi is now j beta, and you can write further as z3 is equal to root r1 r2 by, this is j sin beta. This is j sin beta, because sin h j beta can be written as j sin beta. You can take this j numerator. This is minus j root r1 r2 by sin beta. Now similarly, we can write the values of z2 and z3. So what is z2 is equal to zi2 by tan h5 minus z3. So it is zi2. What is zi2 actually? zi2, we have taken zi2 as r2. So this is r2 by tan h j beta, right, minus z3. What's the value of z3? We have seen z3 is equal to minus j root r1 r2 by sin beta. So minus j root r1 r2 minus j root r1 r2 by sin beta. So you can write this as z2 is equal to r2 by, you can also write this tan h j beta as j tan h beta, j tan beta, minus into minus plus j root r1 r2 by sin beta. So you can take this j in the numerator. So this will be z2 is equal to minus j r2 by tan beta plus j root r1 r2 by sin beta, j root r1 r2 by sin beta. You can take LCM and also write this as, what is tan beta? You can write z2 is equal to minus j r2 by Sin beta by cos beta plus j root r1 r2 by sin beta. Can we take LCM of sin beta and write this as minus j r2 cos beta plus j root r1 r2 j r2 cos beta, and you can also write this as z2 is equal to, if you just take common minus j, it is r2 cos beta minus root r1 r2 by sin beta. So this is the value of z2. Similarly, you can find the value of z1 also. So what is z1 is equal to zi1 by tan h5 minus z3. What is zi1? This is zi1 is r1 by tan hj beta minus z3. What is the value of z3? It is minus j root r1 r2 by sin beta. So you can write this z1 is equal to r1 by j tan beta minus into minus plus j root r1 r2 by sin beta. So z1 is equal to minus j r1 cos beta by sin beta plus j root r1 r2 by sin beta. You can write further as z1 is equal to, just take minus j common, r1 cos beta minus root r1 r2 by sin beta. So you got these values of z1. This is the value of z1, and we also got the value of z2. This is the value of z2 minus j r2 cos beta minus root r1 r. This is r1 cos beta minus root r1 r2 by sin beta. This is r2 cos beta minus root r1 r2 by sin beta, and z3 is minus j root r1 r2 by sin beta. So let's try to write all these equations. What is the value of z1? It is minus j r1 cos beta minus root r1 r2 by sin beta. Is this correct? Yes. What is z2? You can write z2 as minus j r2 cos beta minus root r1 r2 by sin beta. Similarly, what is z3? z3 is equal to, just look at z3, minus j root r1 r2 by sin beta minus j root r1 r2 by sin beta. So these are the values of z1, z2, z1, z2, z3. These are called as design equations for T-type impedance matching network. Now let's try to design this. You can also do the same for pi as well as L sections. Pi as well as L sections. Now let us try to solve one problem based on this. So this being a crash course, we cannot solve all the questions. So I'm just considering one question. A generator, I'm just writing the question. A generator of 100 volts, 1 megahertz, and an internal impedance has an internal impedance of 800 ohms is connected to a load of 300 ohms. Design a T network. Design a T network to match the load with generator. The phase lag between the input and output is, there is also phase lag, that is beta value. The phase lag between input and output is 60 degrees. So let's see what are the things that are given for us. First let us write this beta value. So beta is given as 60 degrees, or it is pi by 3 radians you can say, and it is also given Eg is equal to 100 volts and frequency as 1 megahertz, and also value of the generator has an internal impedance of 800, that is R1 is equal to 800 ohms, and it is connected to a load of 300 ohms. This is R2 value, right? So design a T attenuator. So let's try to design that. First just write the equations of, so this is the network. So to this network you need to find the values of Z1, Z2, Z3. What is this value? Z1, Z2 and Z3. And this value of Zi1, or this is Zi1 is equal to R1 800 ohms, and Zi2 is R2 is equal to 300 ohms. So how do you find Z1? Z1 is equal to minus J. What is that value? R1 cos beta minus root R1 R2 by sin beta. So this is the value of Z1. Just look at this, Z1 minus j R1 cos beta minus root R1 R2 by sin beta. So substitute that. Z1 is equal to minus j R1 800 into cos beta cos 60 minus root 800 into 300 by sin beta 60 degrees. Now just try to substitute these values and you can find the value of Z1 as, Z1 I'm writing it directly, it is J 103.81 ohms. Just try to simplify this mathematically so that you'll get these values, or let me write these values. Z1 is equal to minus J R1 cos beta minus root R1 R2 by sin beta, that is minus J, let me write it here, minus J R1 800 into cos 60 cos pi by 3 minus root 800 into 300 by sin pi by 3. So this is minus J 800 into 1 by 2 minus root 800 into 300 will give you 489.9 by root 3 by 2. So this will be minus J 400 minus 489.9 by root 3 by 2. This will give you minus J 103.81 ohms. So this is the value of Z1. Similarly, now try to find Z2 value. Z2 is equal to minus J R2 cos beta minus root R1 R2 by sin beta. Now what is this value? Write these values. Minus J 300 into cos 60 minus root 800 into 300, same value, by sin 60 again. So Z2 is equal to minus J 300 into 1 by 2 minus, so root of this value we already know it as 489.9, by sine value is sine pi by 3 is root 3 by 2. So Z2 value, after you just simplify this, you'll get J 392.48 ohms. And let's try to find this Z3. What is the expression for Z3? Look at the expression for Z3. Minus J root R1 R2 by sine beta, minus J root R1 R2 by sine beta, minus J root 800 into 300 by sine pi by 3. So Z3 is equal to minus J 489.8 by sine pi by 3. So if you just look at that, let us calculate this. Root of 800 into 300. 800 into 300 will give you 2,40,000. Square root of 489.89 it is, and this is minus J 489.89 by root 3 by 2. So let's try to do that. So 0.866 minus J 489.89 by 0.866. So Z3 value will be, just try to calculate this, 489.89 divided by 0.866. So this is minus J 565.69 ohms. 565.69 ohms, exactly correct. So we got all the values of Z1, Z2, Z3. What is the value of Z1, Z2 and Z3? Let's see what is the value of Z3. J 565.69 minus J 569.69. Is it minus? Yes, it is minus. Exactly. Now Z2 minus J 392.48. So this is, you'll get minus into minus, so this value will be plus, and also this value will be plus. Yes. So this is also a positive value. This is also a positive value because you have 150 minus 489. This is negative value. So Z2 is J392.48. J392.48. What is Z1? 103.81. 103.81 ohms. Now you can also draw this like this: Z1, Z2, Z3, or you can also further find these values. This is J103.81 ohms. This is J392.48 ohms. This is minus J569.69 ohms. Or you can find these values because frequency is already given as 1 megahertz. So you can write these values and find it. So let's try to do that. What is Z1? J103.81. J103.81 ohms. So it is a positive value, so you can write it as J omega L is equal to J103.81 ohms. So omega L is equal to 103.81. L is equal to 103.81 by omega. So you'll get 103.81 by 2 into pi into 1 into 10 power 6 megahertz. So you can calculate this. You get these values as, let me check. We'll try to calculate this. It is 2 into pi into, so 6.28, 6.28, so it is 16.53 into 10 power minus 6 Henry, or L is equal to 16 micro Henry, or 16.52 micro Henry. So this is the value of L, that is Z1 is an inductor of value L is equal to 16.52 micro Henry. Similarly, let's take Z2. What is Z2 given? J39, that we got as J392.48. 392.48 ohms J. So similarly, you can write it as J omega L. So omega L is equal to 392.48. So 392.48 by omega is L. So L is equal to 392.48 by 2 into pi into 6.28. 392.48 divided by 6.28. 62.49. This is 1 into 10 power 6 into 10 power minus 6 Henry, or L is equal to 62 micro Henry. 392.48, 3.22, 6.28. 392.48 divided by 6.28. So this is 62.4 into 10 power minus 6 Henry, 62 micro Henry. So Z2 is also an inductor with L is equal to 62 micro Henry. So this is L1. Let us call this as, and this is L2. Now let's also try to find Z3. What is Z3? It is minus J 569.69. Minus J 569.69. So because this is negative, you can take it as minus J by omega C. So you can write 1 by omega C as 569.69, and omega C is equal to 1 by 569.69, and C can be written as 1 by 569.69 into 2 into pi into 1 into 10 power 6 will give you, just try to calculate that, 569.69, 569.69 into 2 into pi into 1. So 3577.6, 3577.6 will give you 0.28 picofarad value. So we got Z3 is a capacitor with C is equal to 0.28 picofarad, 0.279 actually, 0.279, that is 28 picofarad. So further you can write the final impedance matching network, which is of T type. So you have written Z1, Z2, Z3 with R1 as 800 ohms and R2 as 300 ohms, and this is Z1, Z2, Z3. Z1 value was J103.81 minus J103.81 ohms, Z2 392.48, 390, this is plus J392.48, and Z3 was minus J560 minus J569.69. Or you can also draw this as an inductor Z2 is also an inductor, and this is a capacitor, and this values of inductor is, this inductor value is 6 L1 16 microhenry, 16 microhenry, this is 62 microhenry, this is 0.28 picofarad. So this will be your impedance matching network for the given problem. Okay, so in this session we have learned about impedance matching network design of T type, wherein we found Z1, Z2, Z3 in terms of Zi1, Zi2, also in terms of R1 and R2, taking it purely resistive, lossless, the same. And then we have designed impedance matching network for the given problem. So as I always tell you, we have India's #1 study channels on Unacademy, and we have India's #1 study channels, Unacademy GATE, Unacademy GATE MEPE XE, and Unacademy SSCJE, Unacademy Computer Science, Unacademy Foundation, Unacademy Pathshala, Unacademy GATE Questions, Unacademy Telugu, Unacademy Electrical Junction, and also please do like this video, share this video, use my code YSK10 to get the maximum discount of 10% on your Unacademy subscription, and subscribe to Unacademy and click on this bell icon to get more notification of my classes in future. Thank you once again. Thank you for joining me this session on impedance matching networks. Thank you.